Hello everyone, I am Dr.S.Shailaja, Assistant Professor of Chemistry of the Standard Fireworks Rajaratnam College for Women, Sivagasi. Today I am going to talk about the Schrodinger wave equation, and Schrodinger wave equation is a nightmare to the students generally. They feel very difficult in studying the Schrodinger wave equation, but today I am going to discuss this derivation of Schrodinger wave equation in very simple way, that is in 3 simple steps. Max Planck and Albert Einstein have forced us to understand that energy is quantized and light behave as wave and particle, and they have dual nature. And de Broglie, he extended those to the matters as well, and he has informed us that all matters have wavelength, starting from a small electron to a human body and even to a very big object like a star or a sun. We also know that the wavelength is inversely proportional to the mass. So, for a very huge object, the mass will be very high, therefore, wavelength will be very small, which can be neglected. But for tiny objects like electron, on which the mass is very small, therefore, wavelength cannot be neglected and it has a particular value, and we have to consider this wavelength when we study this electron. Now, we have to understand that these electrons move as waves, and these electrons are moving as circular standing waves around the nucleus, and these waves have integral numbers of wavelength around the nucleus, and therefore, they are quantized. And what kind of wave is this? This is a stationary wave. When an electron is struck by a photon of a particular energy, the electron will gain the energy from the photon and it is excited to the higher energy level. This we have studied from our lower classes. What actually happens in this? This electron will absorb the energy and it will increase the number of wavelengths. So, you can see the figure which I have given above, that when n equal to 3 we have 3 wavelengths, and when n is equal to 4 we have 4 wavelengths, and n is equal to 5 we have 5, and n is equal to 6. So, actually what happens is this electron, they will absorb this energy and they will increase the number of wavelength around it. That is the excited state of the electron. And after accepting these electrons as waves, now physicists, they started working on this electron waves to find out a mathematical formulation. And do you know that Erwin Schrodinger, he succeeded first in 1925 and he derived the Schrodinger equation which talks about this electron. And this H is the Hamiltonian operator. This is a collection of mathematical operator that will explain the state of a electron at that position. And E is energy, and psi, which is a Greek letter, and this is the wave function. As we all know that F is equal to mass into acceleration, which is applied to the Newtonian system. This equation, Schrodinger equation, is applied to the quantum system, quantum states. And now we will see how to derive this Schrodinger wave equation in a very simple way. Let us follow these 3 steps. So, stage 1, we will have in our mind we will recall the wave function, and in stage 2 we will recall the de Broglie equation, and in stage 3 the kinetic energy. Yes, now we will go to the wave equation. A wave equation is denoted by y is equal to a sin x, as this is a sine curve, and when we substitute, now we are going to substitute the various values of this x, and when the value of x is 0, then y will be 0. And when the value of x is 90, then sin 90 will be equal to 1, therefore, y will have a particular amplitude, and when x is equal to 180 degree, again sin 180 is 0, and then y will be 0. And then when you have a 270, what will happen? Your value will be minus 1. So, y will be having a negative value, a negative amplitude will be there. That is why we have a sine curve, and the sine curve is oscillating below and above the curve, our axis, x axis. And also here we can see that the electrons which are very close to the nucleus, that is, if your electron is present in the 1s orbital, it is very close to the nucleus, as in that case electron is more towards, the probability of finding the electron is towards the nucleus is more when compared to the other electron. How will you find the probability? The probability is just determined by taking the square. So, this graph which is at the top explains means that the probability of finding the electron for 1s is more when compared to 2s and 3s. Now, this psi is equal to a sine 2 pi x by lambda. This is a wave equation which we should have in mind when we start our Schrodinger wave equation. Now, I am differentiating this equation with respect to x. So, what will be the differentiation of psi with respect to x? It is dou psi by dou x. And what is the differentiation of a sine 2 pi x by lambda? So, a is a constant, so a is taken out, and the differentiation of sine 2 pi x by lambda is cos 2 pi x by lambda. And friends, we should never forget to differentiate the degree or the value inside the bracket. So, cos 2 pi x by lambda, the differentiation of that is 2 pi by lambda. Now, I am going to differentiate it once more. So, dou square psi by dou x square, again we are differentiating that with respect to x alone. Now, in the same way we have a 2 pi by lambda the whole square, and the differentiation of cos 2 pi x by lambda is again sine, a minus sign. So, we have a negative sign in the front, and this equation is, I have now pulled down this equation as dou square psi by dou x square, it is equal to minus 4 pi square by lambda square into psi, because we know that in the above equation, and we have taken psi as a sine 2 pi x by lambda. So, I substituted value and I have got the equation from the wave values. Next step, so stage 1 is over. So, from stage 1 we have got an answer, and now stage 2 is applying the de Broglie equation. And we also know the de Broglie equation, lambda is equal to h by mv, where lambda stands for the wavelength, h is the Planck's constant, m is the mass, and u is a velocity. Now, I am going to substitute this value of lambda in the first equation, and which I said in the previous section. The stage 1 we arrived at this equation, which I have written it again. So, now we will substitute the value of lambda. So, here we have lambda square in equation 1. So, what will be the value of lambda square? Lambda square will be h square by m square into u square. Now, substituting this value, we are now arriving at equation 2, and then rearranging that we are equating it to 0. And now we are coming to the third stage, and friends, you have seen that the first stage and second stage are very easy, and now we are coming to the third stage, which is a kinetic energy stage. Here the total energy can be considered as a summation of kinetic energy and potential energy, and the kinetic energy formula we know as half m u square, and for potential energy we are taking it as V. Rearranging this equation, we are having u square is equal to 2 into E minus V by m. Now, substitute this value in the equation 2, which we have arrived from our de Broglie. When we are substituting this value, you can see that we are getting dou square psi by dou x square plus 8 pi square m by h square and E minus V into psi equal to 0. So, this is the equation generally you find in your textbook. Did you see how easily we have arrived at the Schrodinger equation in just very simple 3 stages? And this is called a one-dimensional Schrodinger equation. Do you know why? Because we have only considered x. And how many Cartesian coordinates do we have? We have x, y and z, 3 Cartesian coordinates. So, now this is a one-dimensional Schrodinger equation, and in order to derive a 3-dimensional Schrodinger equation, now what we have to consider? We have to consider the axis y and the axis z. So, now I have included them in my Schrodinger equation as dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into E minus V into psi equal to 0. And again we know that dou square psi by dou x square, dou square psi by dou y square and dou square psi by dou y square can be taken as del square, which is a Laplacian operator. Now, substituting this in the above equation, we have del square psi plus 8 pi square m by h square into E minus V into psi equal to 0. And this is the 3-dimensional Schrodinger equation when considering all the 3 axes. And now, I am going to discuss a small problem for you, which will be generally asked in the competitive exam. Now, the problem goes like this. Find the value of the potential energy V if psi is equal to A into e power minus alpha square into x square, and the value of E naught is given, which is h cross square into alpha square by m. Here I wanted to place on record that what is the meaning of this h cross square? H cross is nothing but h by 2 pi. Having this in mind, we can very easily solve the problem. So, we know that the Schrodinger equation is minus h cross square by 2m dou square sub by dou x square plus v. This is a one dimensional Schrodinger equation. As they have given the potential energy value for only one dimension, we can use this. This is a one dimensional Schrodinger equation, and we know that the h cross square we can take as h by 2 pi. So, you can, when you substitute, you will get h square by 8 pi square m. So, the Schrodinger, just I have remodeled or I have derived this by substituting h cross instead of h square, h by 2 pi. Now, substitute this value of psi which is given in the problem, and we have to find the value of dou square psi by dou x square. So, first we will find and differentiate the value given for psi 2 times. So, yes, first, well, let me differentiate, let me substitute the value of psi. So, what is the value of psi? So, psi is dou square psi by dou x square into a into e power minus alpha square into x square, and now a is a constant, so a can be taken out. So, we will have the remaining terms inside the bracket. Now, when we have, let me differentiate it once first. So, we will have a into dou by dou x is equal to, what is the differentiation of e power minus alpha square x square? It is nothing but e power minus alpha square into x square, and we should never forget to again differentiate the power. So, when you differentiate the power, here you have a negative sign and you have alpha square which is a constant, and your x square can be differentiated as 2x. Okay, and now we will differentiate it. So, you will get minus 2 alpha square a to dou by dou x, x into e power minus alpha square into x square. And now we are going to differentiate it again. Here you have to know that we have two x terms. What are they? We have x. The other one is e power minus alpha square into x square. So, what formula should we use? We should use a UV method to differentiate this. Now, shall we use it? So, first we will use, write the constant as such as minus 2 alpha square a. Now, differentiate x into e power minus alpha square into x square. First, we will differentiate x with respect to x by keeping e power minus alpha square x square as a constant, and then, so we will get the first term. What is the differentiation of x with respect to x? It is nothing but 1. That plus, then we are keeping x constant, and here we are differentiating e power minus alpha square into x square. What is the differentiation of e power minus alpha square into x square? Of course, it is e power minus alpha square into x square. Now, we should never forget to differentiate the power. So, when we differentiate the power, we will get minus 2 alpha square into, you will get 2x. Now, then we are rearranging it and we are getting the answer as minus 2 alpha square a, 1 minus 2 alpha square x square into e power minus alpha square into x square. Now, so we have now calculated the value of dou square psi by dou x square separately. Now, we are going to substitute this value in our Schrodinger equation as we know all the values. So, we are substituting the value for dou square psi by dou x square, and we are substituting the value for psi everywhere, and then I have found out a value for E naught. And then, and we know that E naught is nothing, E naught is also given in the problem, and by substituting the value for h cross as h by 2 pi, I have solved for E naught separately at the top as h square by alpha square by 4 pi square into m. Now, substituting this value and then rearranging, we are getting that V is equal to 2 into E naught into x square into alpha square. And I hope this problem is very clear for you people. It's a very simple problem. And I have also given one assignment for you. It's a take home work for you. So, you can try to solve this problem, and in this problem the time dependent wave function of a particle of mass m moving, the potential energy is given and the wave function is given. What are they asking you? They are asking you to calculate the energy. And in the previous problem energy was given and the wave function was given, and you were asked to calculate it only the potential energy. And do remember that this is a one dimensional problem, as your potential energy depends, your psi depends upon only x, and V also depends upon only x. And I have given this problem also the answer for this problem. So, you can verify this problem, after working out with the answer which I have given. And thank you friends for watching. I hope this video would have been very useful for you. Thank you.